Well, good day to you, my friends. It's time to solve some LeetCode problems. Yay! Now wait a second. Right. Well, I hope it will work. We don't have any drops yet. Okay. So, today I'm using a dark mode. Let's test it. It looks like this. Well, it's dark. And first of all, I want to continue with this problem. I tried to discuss this problem yesterday, but I experienced all kinds of problems with drop downs, with slow PC, and so on. Let's try to continue this talk today. But before all that, I need another solution. Oh no. No. What? Error? Oh, something else. Yeah, this one. Wait, how can I go back to this one? Let's just copy. Okay, so, oh no, it's not what I wanted. Wait a second. I want this one. Yeah. So, this was my previous solution, my best attempt. And to tell you the truth, it's quite awful. After that, I looked for a best approach, and well, mine is definitely not the best for so many reasons. Well, first of all, and this I think we can fix, the problem is when we go through this tree, you know, it doesn't work. When we go left through this tree, and we want to connect each of the nodes to the previous one, or probably it would be better to say to the next one because it's going to be the right node. No, but we have a problem when we, how can we describe this problem even? Oh no, of course it's not that. Wait a second. we can skip, I guess, like 15 minutes of this video. Yes, here is my last solution that you saw. No, here is it. Okay. So yes, you see, when we are here at 5, let's say, if we have a root left, this root 3, now we take this node and we call this method again with this left node 3, and we continue again and again and again until we reach node 1, and we always return this last node, the leftmost node. You see, previous node. So we end up here, you know, and when we end up here, we want to connect this last node, this previous node, to node number 2, right? Right. Then when we get back, after this line, we want to connect this group 1 and 2 to 3, then 1 and 2 and 3 to 4, then all these guys to 5, right? But every time we return the previous node, we return this one. And that's a huge problem, because we do not connect node 1 with node 5. You want to connect 1 to 2, 2 to 3, and so on and so on. So I invented this stupid approach where we traverse back. I mean, if we are at node number 1 and we go right and right and right and right, you see, while there is right, we go right. And when we can't go right anymore, we connect it to the node. The problem is we do it a lot of times. I mean, for every call of this method, we do this while loop. It's not always that long, but still it's a big problem. So the way I solved it, and it's still not ideal. Well, let's think what we want to achieve. We have the root left, and this root left have a right node, and let's just put our node in there like this. Let's comment out all of this. What will happen? Oh no, it's typo. Second. What do we have? We have nodes 1, 2, 3, then we skip 4 and continue with 5, 6, 7, 8 and 9, and so everything else is good, but we skip this node. Why do we skip this node? Because here, when we assigned node to root left right, we replace this connection to node 4 with connection to nodes 5, 6, 7 and so on. And I managed to solve this problem by adding a new variable. Let's see what's going on here. It's very hard to find a good name for such a variable. I called it rightmost node of left node. So if we have a left node, what is the rightmost node of this left node? Usually it's nothing, it's just the node itself. It doesn't have any right nodes. And in such a case, we will just have a root itself here, well, a node itself. But if we have some right node. Let's move in this right direction as far as we can, right? Like this. And to this rightmost node, we assign our node as the right one. So we connected everything. And we don't even, yeah, like this. Let's launch it. And it's working. But still it's not an ideal solution because, yes, now we don't go back every time for every call of this method like it was, but still we go right here, and we go right like to the end, to the rightmost element, and here we repeat it again. So we do this twice. And of course it's not like crazy bad. It's not like we had a big O of n solution and now it's like a big O of n squared. It's not that dramatic, but still there are a lot better approaches, and I'm going to show you this better approach in a few minutes. But right now I want to explain another problem here. You see, we create a node. For every node that already existed in our original tree, we create a new node. So we double the number of objects of this 3-node class, and in terms of like performance, it's not a big issue, but in terms of space, it's bad. And the best solutions to this problem, they do not create new nodes. They use existing nodes, of course. And I'm going to show you this clever solution. Let's call it like this. A clever solution. Of course, it wasn't developed by me originally, but at least I managed to understand it. And now I'm going to explain it to you. So, first things first, we want to add another argument here, another parameter. Let's call it, they usually call it tail. Let's call it tail, and by default it's a nil. Now, we want to return tail unless we have root. Is it right? I'm not even sure. I don't remember the syntaxes. Let's see. At least it works. Then we want to have a result. What are we going to have in a result? We're going to call this method on root left, and as a tail we're going to use a root itself, and we want to return this result in the end. So of course we don't need the word return. Let's do it like this. Okay, it's the first part of this problem. We traversed through our tree to the leftmost node, and we always return this node. In our result, we always have the leftmost node. But also, what we want to do? Well, let's talk a little more how this works. You see, there are no if conditions, because for me it was always if root left or something. Here, if we don't have a root, if we don't have root left. then we just return tail. And as a tail, we use the root itself. So when we go left here from 5, we call increasing BST on node 3. And as a root, we use node 5. And of course we continue to do it again and again until we reach this node 1. And we again try to call increasing BST with root left, but node 1 doesn't have root left. So we return the tail, and the tail in our situation is node 1. And this prevents us from hitting some horrible nils from having all these checks if root left. You don't need them anymore. And it's a nice thing. But what happens next? So we are here at 1, let's say. And in a root variable, in a root parameter, we can say we have this node 1. And let's just do two things. Let's set root left to nil, and let's set root right to call of this method again. As a first argument, we are going to use root right, and as a second argument, we are going to use tail. So what the hell is going on here? And I think this is the end, actually. So it's that simple. But it's very hard to visualize, this is a problem with all these trees. Yes, it's accepted, it's a good solution. Let's try to explain what is going on when we are here at 1. Well, we tried to go left, we didn't succeed because there is nothing left. Then we set root left to nil, but we didn't have any root left, so it doesn't change. But for the root right, we try to go right, and we hit this check. Do we have a root here? No, we don't have this root right, so we return the tail. But what is the tail in this situation? The tail is node number 2. So we take node number 2 and set it as node right for this first root, for this first node. So how does it work? We arrive at some node, and if we have something to the right, like 4 here, we use this. If we doesn't have anything, we use like this upper node as the right node. Now let's try to understand it with this paint. So we are here at 1, right? And we try to go in this right direction, and there is nothing here. So we take, instead of this right node, this thing. So we can say that we take this one. No, not like this. Let's copy this bastard. Yes. Take this one and we connect it like this to the upper root, not to the upper node. Now it's not an upper node, now it's the right node. But then so many windows. Then we go back to this node 2, because we called all this, we went to the leftmost node, but now we return to our previous calls of this method. So we arrive back at node number 2. And the first thing we do is we set the left node to nil. Let's do this. So we do not have this node anymore. But do we have a right node? No. So we use an upper node, master node, root node as the right node. And again, we take all this crazy shit. And we set it like this. But then we go to node number 3. And first of all, we remove the left node. And we don't have this part anymore. But we have the right part. So we continue with this node, with node 4. We arrive here. Here we check to the left, nothing. To the right, nothing. So again, we use an upper node, tail node, as we call it. It will be hard. Move it here. No. Something like this. But we also had this connection. And we won't have it anymore. And so on and so on and so on. It would be just one line. And we do not have to traverse it in all directions again and again and again using while loops. And the best thing is that we don't create new nodes. We use existing ones. That's beautiful. And that marvelous solution, it was described and proposed by, I don't know, let's see. Here is it. By this guy. Sir. Right. Let's upload this. It's a great solution. See, it's such a small, elegant solution. Compare it to my monstrosities. And looking at this, how can anyone not love programming? See, it's majestic, it's marvelous. Jesus. The only problem with this tree is it's hard to visualize, and that's the root of all of my problems. Well, but I hope I will get better and better and better. And now, for something different. Let's go to problems. First of all, let's discuss some of, of the problems that I solved previously before I started streaming, just to get a better understanding of these problems. Yesterday we discussed this one, So next one is recyclable and low-fat products. Let's see. Oh yes, let's remove it for now. So what do we want to achieve here? We have a table, products. We have a product ID, like here, it's an integer. We have a low fats and recyclable. And this is an enumerator that can take values yes or no, y or n. See, so this is a table. There are some products, and for each product it is set whether it contains low fats, whether it is recyclable, and so on. And our goal is to select only products that are recyclable and that are low fat. So only the products that have Y in both columns, you know. Let's try to solve it. Let's select product ID, of course. Well, let's do this in steps, you know, from, how is it called, products. Like this. Start from the simple things. And we have, of course, column with product IDs, all of them. But we do not want all of them. Let's use where keyword. You know, where low fats equals Y. Let's start from this. And we have products 0, 1 and 3. 0, 1 and 3. Yes, it's correct because we have Y's only for 0, 1 and 3 in low fats. But also let's add recyclable. Let's check for recyclable Y's. And we can combine a few conditions, a few checks by AND keyword. So, by the way, where is my chat? Yeah, here is it. And recyclable equals Y. Let's run it. And it's green, it gets the job done. We only took product 1 and product 3. They both have double Y's, so yeah. This is like the most obvious solution, but I encountered a funnier one. Looks like this. Starts with an N. I don't remember how it structured. Well, we'll see if it works. Fats and recyclable. Yes, it works. So we check that N not in any of the tables. So this way we escape repetition, you know. We don't have this repetition, we don't have AND keyword. So it's a funny solution. I don't know if there are any problems with it. Maybe it's slower than double AND or than two where clauses. I don't know. If you have any downsides of this approach, let me know, please, because it's beautiful, you know. And of course, in solutions here, there are so many similar solutions, not similar to this one, similar to the first one. Now there was a guy who, yeah, here is it. Who invented, maybe not invented, but he proposed this solution. And no one discusses it, no one highlights it, no one upvotes it. But it's a great solution. I don't know why. Who's Viper? Viper. He has an awful rank. But he has this great solution. I don't know how come. Let's upvote him. Go Viper. You Viper. I don't know. So this was problem number 1757 recyclable and low-fat products. And now let's solve some new problem. As far as I remember, we were at page number 3. And everything is solved here. The latest login in 2020. Let's see what it is about. It's SQL again. Okay, let's see. So we have a table logins, user ID, timestamp. Okay, I see. Write an SQL query to report the latest login for all users in the year 2020. Do not include the users who did not log in 2020. Okay. Every day something new. Of course, we'll have to Google. But as always, let's do this in steps. Let's start with something simple. From logins. So, when year is more, let's use where. Timestamp. I don't remember how we do this. It's an experiment. Let's see how it will go. Or probably it would be better to do just this, of course. Maybe we don't even need the zeros. Oh, let's see. No. Of course, we need where after from. Our output. Yes, and of course we need a second condition. Let's say more than 19. Here we use 12. Here we use 31. I don't know. Maybe like this. Okay. So we have just four users here, 4 logins. Okay, and when we have the same user, with more than one login, we need to choose the latest one. Okay, if we group by user ID, what will happen? Yes, it doesn't work because choose the earliest one, probably something like this. How can we do this? I don't remember. Like, no, not like this. Let's read about group by clause because I don't remember. Let's see some examples. Group by country. Do we need join here? Max date. Do we have something like this? That's interesting. No, no, no. MySQL max date. That's what we need. It's like the whole solution. Will it work? Won't it work or not? Let's see. Select user ID and say timestamp from, of course, logins L some loud neighbors. I don't know if you can hear them. Timestamp. Let's call it L1. Let's call it L2. L1, L2, and I don't think we have a second condition here. Of course, we can use this monstrosity. Oh, probably we don't even need group by here. Let's see. Great. We lost this one, number 6. Where is it? How come? Come on. Okay, what if we do it like this? Probably we still need all ones. No, we lost the 6th one. Okay, so we need to group by user ID, I guess. It's not green. No, we still do not have 6-1. Of course. Of course. Can we use it right here? I don't know. It would be nice. Nothing. What about this one? We already tried this. It didn't work. I don't remember why. Oh no, it works. And what is the problem here? It's good. It's good. But it's good. It's exactly the same. Oh, last temp, of course. I'm a moron. Last stamp. I probably don't mean group by. I know, but it won't work like this, of course. Of course, let's take it back. Of course. And it's green. Oh, thank you very much. I don't know if it's a good solution. Let's submit. Okay. Beautiful or not. And you may ask, why don't I check for the best solutions immediately? It's because I want to give myself some time to to sit on the problem, to think about it a little bit afterwards. Maybe I will come up with something better on my own, who knows? So I guess this is it for today. Thank you very much for being here, or not, but still, thank you very much. I'll see you soon again. Tomorrow probably. So stay tuned and goodbye, and thank you very much.